Okay. So a little while ago, up here, we looked at 5 ways to prove something is a parallelogram. Yesterday, we just did one way, and that's the middle one that shows both sides right here in the middle. That shows something's a parallelogram simply because both sides are parallel, but we have these other 4 ways. So we're just going to use some formulas today that prove it's a parallelogram, such as showing that both sides are congruent by using distance formula, and also by showing if the diagonals bisect, then it's a parallelogram by using the midpoint formula. So we're just adding in the distance formula and the midpoint formula as additional methods for doing the same thing. Okay, we're not going to do anything with the angles yet. That's going to come later. But that's where we're looking at today. So it's just a day 2 of the same thing, but using all three methods instead of just using the slope only. But the first is the same method that we did yesterday. So we can always show they're the same slope right here, just by or we can prove it's a parallelogram just by showing that both pairs of opposite sides are parallel. So that hasn't changed. So I can show that the slope of CD right here, and I'm going to notate that by little m, slope CD, and showing that equal to the slope of the opposite side, which is AB. Now it does say both pairs, right? So we have to do also slope of AD. Okay, so 2 parts, slope of AD. And we're going to show that is equal to the slope of BC. This is what we did yesterday. So if you find the math or the number parts of all these problems a little too easy, make sure you're actually doing the geometry part of all these problems and writing this step out and not making that optional and just trying to get to the very end or the very bottom of the problem to say you're done. Start off with geometry and then substitute in the numbers that go with it. Right. So slope of CD is just going to be up 1, 2, 3 over 1. Just doing the same thing and showing the same number. And the slope of AB is up 1, 2, 3, and over 1. So we're just verifying this. Someone mentioned that they were getting different answers for if they're going the other direction, like the slope of DC should be the same as the slope of CD, right? It's the same line. You can't have 2 different slopes for the same exact line. So if you go the other direction, just note that you'll get some negatives. So if I do from D to C, the slope would be down 3, right? So I just make this a negative 3, and it'd be left 1. So that means the bottom is also negative, and that's how they come out to be the same slope, because the 2 negatives cancel out, and it's equal. So it doesn't matter which point you start at, you get the same exact number, sign, and all. Okay? And then, of course, do the same thing over here. Just verify. Count it. 1, 2 for the rise. 1, 2, 3, 4, 5 for the run. So the slope of AD is 2 over 5. Positive. And same thing here, starting at C, up 1, 2. To the right, 1, 2, 3, 4, 5. So that's just a quick review of what we did yesterday. And we also did trapezoids yesterday. So this is the same exact work for trapezoids, only with trapezoids, only one of them have to be equal. So I think on a few of those problems yesterday, you might get like a 3 and like a negative 3. So that one would not be equal, but the other one would be. So you have a trapezoid if only one of these are true. If neither are true, that means it's just a quadrilateral. And it's 4 sides. Nothing's parallel whatsoever. Okay. So what we're going to do next, though, is very similar. We're going to do the distance formula to show that it's parallelogram, because that theorem on the other page says if both sides, or both pairs, I guess, of opposite sides are congruent, it's a parallelogram. So if we didn't have, let's say we didn't have these grids and we could not count squares and calculate slope super easily, we'd have to rely on the distance, like just how long are these, right? If they're the same distance across from each other, right? So it comes out to be very similar type of work. We need to show that CD is congruent to or equal to AB, right? And then we need to show that AD, measure of AD, is equal to the measure of BC. So same exact notation up here. We're just taking off the little slope. We're no longer finding the slope. When there's nothing attached to it at all, that means what's the distance? The default is distance. And recall that the distance formula is a form of Pythagorean theorem. Okay? So it looks something like this. Distance formula is simply a squared plus b squared, and then you take the square root of everything. So we just need to do that on both for CD and AB and show we get the same radical on both sides at the end. Very similar to the slope. It's going to be repetitive, not only within itself, but also compared to the slope, because we actually use the A and B, right, up 1, 2, 3, and over 1. The rise and the run from my slope are really the A and B in the distance formula, right? So it's the same numbers. So we're going to have here 3 squared plus 1 squared, right, which is 9 plus 1, which is 10. So the distance from C to D is the square root of 10, which the square root of 9 is equal to 3. So the square root of 10 is a little bit bigger than 3. You could say approximately 3.1, something like that. Just so you get some context and it's an answer that makes sense. Always figure out what that decimal is approximately. It doesn't have to be perfect. But if this came out to like square root of 101, hopefully you'd look at that and say, well, that's square root of 101 would be like 10.1. This easily doesn't look like 10 squares, right? You don't know exactly how many there are, but you know it's not 10, and you know something's wrong with the arithmetic. Right, and then let's go ahead and do the other side. The same numbers right here. The rise and run of AB is going to be the A and B in the distance formula. So it's going to look for today very similar on both sides. It's going to be very, very repetitive. That way, when we actually put in some very different numbers, or we throw in decimals and fractions in these, it's not going to throw you off. Right, and of course, it is both pairs, so we have to do this twice. So we got to do from here up to and over 5, right? So the same numbers. 2 and 5 are the A and B. So we'll do 2 squared plus 5 squared, which is 4 plus 25, which is square root of 29. And approximately 29, we know it's going to be 5 point something because square root of 25 is 5. Square root of 36 is 6, so it has to be somewhere between 5 and 6. 29 is, I don't know, pretty much in the middle of 25 and 36. So this is like a 5.4 or 5.5, something like that. On the right-hand side, same idea. We've got rise of 2, run of 5, so we're going to have a square root of 2 squared plus 5 squared. And you'll see the exact same work on both sides. It will always be this way. We're just starting off this way on these problems. So the bottom line is we're trying to get to the end and show that they are the same number for both pairs. Okay. And if anything else, if you're saying that the arithmetic is easy, focus on the big picture of writing first the geometry statement. Many of you just kind of skip to doing numbers real fast and you don't write this part down, so you're in your geometry homework, you're skipping the geometry part of the problem. So don't think of this as optional. Actually write down what it is you're trying to show, and at the end you get the same number on both sides, as opposed to, one part of your paper you're doing this work over here, and the other part of your paper you're doing this over here, and at the very end you're saying, yes, it's okay. Put them side by side just like this, so it's really easy to see that they are the same. Lastly, we're going to do the diagonals. So the diagonals are not written on here. So if you want to, you can draw them in, so you know what it is that you're showing. Okay. So we're trying to show that these two diagonals have the exact same midpoint. Right there, that black point. That's the midpoint. Call it capital M. So if we do the midpoint of AC and then do the midpoint of DB, and they happen to be the same number, we know they're bisected. Okay, so that's going to be the next thing to do using the midpoint formula. I'm going to zoom this out so I can see the graph and the work here. So just like before, we always had this geometry statement first. Here's the slope of CD. Here's the distance of CD. Now we're trying to find midpoints. So for midpoints, I'm going to use a capital M instead of a lowercase. That's going to denote midpoint. And then I'll put what the midpoint of what segment. So here I'm going to do the midpoint of, let's say, AC. I want to show the midpoint of AC is equal to the midpoint of the other diagonal, BD. That's what I'm trying to show. And then underneath the midpoint of AC, we'll do all the work for that, and then all the work for this, and it should be the same X and Y for both. All right, so going back to here, we have, now it might be tempting when we're doing the midpoints to look at the graph because we can actually see it, but really all the numbers are over here. And since I have the points listed right here, it's a little bit easier to go to this list and get the numbers as opposed to just trying to get them off the graph. So find the x-coordinate of A, the x-coordinate of C. Go up here. Here's A, the x-coordinate is 4. Here's C, the x-coordinate is -2. So we'll have 4 plus -2. And remember, to find the halfway point, you divide it by 2 or take half of it. And then repeat that for the y-coordinate. So you go back to the A and C and you get the y-coordinate. So the y-coordinate for A is 4. The y-coordinate for C is -1. So we got 4 plus -1. So this is a way faster way, a more accurate way of doing it without having to go to the graph at all, if you have all the coordinates listed separately. Now, if these points were on the graph, you would just do it from the graph. Okay, so that's 1. And we can simplify these. 4 minus 2 is 2. 2 divided by 2 is +1. And just consulting the graph, yeah, it looks like the x-coordinate right here is +1. That makes sense. Right? Then we have to find out what fraction this midpoint is at on the y. So we go back here, do the calculations. 4 minus 1 is 3. 3 over 2 is 3 over 2, or you can write it as 1.5 or 1.5, however you want to do it. And double check to make sure that makes sense on the graph. And yeah, it's plausible that this is at 1.5. Looks like it's in the middle of 1 and 2. So I just want your answers to be reasonable and not just write them down and say, well, that's the number I got, so that's it. It should match the graph. The graphs are not always drawn to perfect scale, but they're close enough that you can compare. All right, lastly, let's go yellow. So to do the same thing for BD, right? So go back up here. We need to find the x-coordinates for B. Go up here, find B, find the x-coordinate, which is 3. D, the x-coordinate is -1. We got 3 and -1. 3 plus -1. And then find half of it, divide by 2. And then find the y-coordinates. Which are 1 and 2. And find half of it by dividing by 2. And just like before, we can calculate those. So we have 3 minus, or plus a -1, 3 minus 1 is 2. 2 divided by 2 is 1. Then we get 1 plus 2, which is 3. So again, we have 3 over 2, which is 1.5 or 1.5. And we have shown the two midpoints are equal to each other. Therefore, the diagonals do bisect one another. So you want to associate the word midpoint with bisect. They both involve finding the middle of something. Bisecting is cutting in half. Midpoint is finding the halfway point. Okay. All right, so that's basically it for one of these. The rest of them are the same. None of these are asking you to, figure out if it's a parallelogram. So all of these, everything should be the same number on both sides. It should be exactly equal. It does list the properties over and over. So pairs. So these are the same exact answers for every problem. Both pairs are parallel, both pairs congruent, and bisect for each one of these. So it's just reiterated so to make a point. There are 3 different ways. Okay. All right, so you have the rest of the class to work that out. Again, please write the geometry statement for each one of these. Don't just skip to the algebra. And that's it.